welcome to the TCP IP stack. So first of all, why is the stack in different layers? So the stack has 4 layers. The top layer here, this pink layer, is called the application layer. The second layer is the transport layer, or the TCP layer. This is the internet, or the IP layer. And then this final layer is the link layer. So sometimes the link layer is split into 2 more layers, which is the data link and the physical layer. And the stack is for any data that gets transmitted through a network from one device to another. So when data gets sent from your computer to another person's computer, it goes down the layers like this. And then it gets sent to the recipient's computer. When your computer receives data from someone else's computer, the data goes back up the stack like this, the other way, in reverse. It's in layers so that if one layer breaks or needs to be updated, then the functionality of the other layers isn't affected. So let's start with the application layer. So this is the application layer, and this is where all network applications operate. For example, web browsers, or like video games, or just basically any app you have on your computer. So these apps generate data to be transmitted. So this is my little application, and it's going to generate some data to be transmitted through the stack. And let's have a look at that. I have my data, so this is the data that needs to travel from my computer to my friend's computer. So now what I'm going to do is I'm going to use the appropriate protocol. So there's a bunch of different protocols. This isn't an exhaustive list, but these are just some of the protocols that operate on the application layer. I'm going to say that this data is a web page, so I'm going to use the HTTPS protocol. So this is my HTTPS protocol, and I'm just going to be adding that to my packet of data. So now we move on to the transport, or TCP layer. So this layer sets up communications between the 2 computers that need to transfer data to each other. It first splits the data up into packets, and these are little bundles of data which are of equal size, and then we add some metadata. So for each packet we're going to add the packet number, for example 1, the total number of packets in the sequence, which in this case is 5 because we've got 5 packets. So every packet of data will have that metadata attached to it, and then we move on to the internet, or the IP layer. So in this layer, we add IP addresses to each packet of data, and IP addresses are the location of the network that the packets need to be sent to. So it's whatever network the recipient's computer is on. So they're all going to the same place, so let's just pretend that that's an actual IP address. It's not the format of an IP address, but it will do. And then the IP layer has to route packets to the correct network. So the router, which operates on the IP layer, will choose the fastest route for each packet of data, and they might be sent down different pathways, so they might not all arrive at the same time. And then we move on to our final layer, which is the link layer, and this is the transmission of the actual binary values of the packets via any media, so like wires or wireless, Wi-Fi, etc, etc. And it also adds the MAC address to each packet. So there's a MAC address for the source computer and the MAC address for the destination computer. So the MAC address points to the specific computer on the network that the packet was sent from, and the specific computer on the network that the packet needs to be sent to. Obviously, again, it's going to be the same for all of them because they're all heading to the same place. Okay, so now our packets are all ready for transportation. Why is zombie interrupting my TCP IP stack. How dare you? So now that the packets are ready, they can be physically sent via Wi-Fi, cables, etc. to the recipient's computer. Bye-bye. I hope that was helpful revision for you guys. If this helped you, please leave a like or a subscribe. I'd really appreciate that. Thanks for watching.